Hi, Kylie, and other students possibly. You would ask some questions on the worksheet, and I'm going to have to assume that it's the worksheet on parabolas. So let's take a look at some of these problems. Number 6, find the worksheet back. Number 6 says that y is equal to 1/2 x squared minus 3x plus 11 halves. So we got this, and what we're supposed to do is to, I think, identify the vertex, the axis of symmetry, the maximum or minimum value in the range. So what we want to do is put this into vertex form if we can. And remember, the magic piece is going to be negative b over 2a. So this is a, this is b, and this is c, right? So our a is 1/2 and our b is negative 3. So if I use a negative b over 2a, that's going to be a negative 3, which is just a positive 3, over 2 times 1/2. So 2 times 1/2 is 1, and so that's going to give us 3 over 1, or just 3. Now remember what that is. Excuse me, that's going to be our h, right? And to find our k, we're going to plug this into the original equation. So to get our k, it's going to be 1/2 times 3 squared minus 3 times 3 plus 11 halves. So all I did is plug in what I got for h, my negative b over 2a, into the x values for the original equation. So let's simplify this. So our k is going to be, 3 squared is 9, and 9 times 1/2 is 9 halves. And 3 times 3 is 9. And then we have 11 halves. So I have 9 halves minus 9 plus 11 halves. Let's do the fractions together first. 9 halves and 11 halves is going to be 20 halves. But 20 halves, or 20 divided by 2, is just 10. So that's 10 minus 9, which is going to give us 1. So this is our k, and so we know the vertex, I'll write it down here. Then we know the vertex, which is always at hk, right, is going to be 3, 1, because our h was 3 and our k was 1. So the vertex is at 3, 1. Now, the axis of symmetry is always going to be an equation that's x equals some number, and it's always going to be x equals h. And in this case, our h is 3, so the axis of symmetry is x equals 3. And then it asks for like a maximum or minimum value, and so we're going to have to think a little bit. Let's go back to our a. Our a is 1/2. So we know that this is going to open upwards. If it was a negative number, if a is ever negative, then the parabola opens downward. But if it's positive, it opens upwards. So being that it opens upwards, any parabola that looks like this, where it opens upwards, is going to have a minimum value at the vertex. If it opens downwards, it's going to have a maximum value, because then it looks more like a mountain and it has a peak. This one has a little valley down here, which we could say maybe is a trough. The bottom of it is going to be where the vertex is, and so that y value at the bottom, the smallest y value that this can have, is 1. So it has a minimum value, which is equal to 1. And I think that's all we were supposed to do there. Vertex, axis of symmetry, minimum value. Oh, the range. Oh, the range. Remember, the range is going to be, getting back to my paper here, the range is going to be the y values that this function can take on. And so as we look at the minimum value, that's the minimum y value, but there's no maximum y value. It can take on values up to infinity. So if we look at the range for this, you're going to have y values that are greater than or equal to 1, because 1's the smallest it can be, and then we can go above there as far as we want. Okay, so that's 6. 15. What does 15 look like? What's it want us to do? What is the vertex form for this function? So we've got y equals 1/2 x squared minus 6x plus 15. Just putting it into vertex form. So we're going to do very much the same thing that we did before, only this time it's this function. And remember what vertex form looks like. Y is equal to some a times x minus h quantity squared plus k. That's vertex form. So we're going to try and make this one look like this one. And again, we need to find our h and our k. To find our h, that's our negative b over 2a, right? That's our little piece of magic. And so we've got to identify our b. In this case, it's negative 6. So a negative 6 is going to be a positive 6. All over 2a, in this case, a is 1/2. So it's 2 times 1/2. So on the top, we have 6. On the bottom, we have 1, because half of 2 is 1. And that's just going to give us 6. So that's our h. Okay, now to get our k, we're going to plug this value in for our x in the original expression. So k is going to be equal to 1/2 of 6 squared minus 6 times 6 plus 15. Okay, just plugging in our h for our x's here. 6 squared is 36, and half of that is 18. So k is equal to 18. 6 times 6 is 36 minus 36, and then we do plus 15. So 18 minus 36 is negative 18, plus 15 is going to give us negative 3. So if we were going to write this in vertex form, right, the a is the same as the a was here. It's 1/2. So that's 1/2 of x. Our h was 6, so x minus 6 quantity squared, and then plus negative 3, or just minus 3. So here's our vertex form for that one. Okay, that's 12. We still got to look at 15, 18, and 20. Excuse me. Or was that 15? What was that? That was 15. Well, you wanted to look at 12. Let's look at 12. What did 12 look like? Oh, 12 is an interesting one. Windows is asking me to recommend them. No, thank you. Let's do 12. I skipped that before. We shouldn't skip problems. Goodness sakes. Number 12 says we've got a vertex at -1, -7, and we've got a point. What's the point? The point is at -5, 1. So let's. Oh, and we're supposed to write. We're supposed to sketch the parabola. Great. I don't have a ruler with me. Oh well. If the vertex is there, remember vertex form is y is equal to a times x minus h quantity squared plus k. So if the vertex is at -1, -7, I can fill that information in here. And at the same time, the point, -5, 1, gives me an x and a y value, so I'm going to fill those in as well. So I'm going to replace y with 1. And I don't know what a is. Oh, oops, I wrote x and I didn't mean to. I'm going to replace my x with -5 because the point gives us an x and a y value. So we're going to use -5 for our x. And then I'm going to use my vertex. My h is -1. So I need to subtract the -1 or add 1. Square that. And then here's my k. That's -7. So I replaced my y with 1. I replaced my x with -5. I replaced my h with -1, and I replaced my k with -7. And the reason I do that is because that leaves me with just one variable here, so I can pretty easily solve for a. Let's do some math. So 1 is equal to -5 plus 1 is -4. If I square that, I get 16. So that's a 16 minus, oops. There's an a there, Mr. Pokin. Yeah, I see it now. A times 16 minus 7. If I add 7 to both sides, I'll get 8 is equal to a times 16. And if I divide both sides by 16, then I get 8/16 is equal to a, which is the same thing as 1/2. So what that tells me then is that my a was 1/2. So I can write this vertex form as y is equal to 1/2 of x. Let me go back to my vertex. Plus 1 minus 7. Goodness sakes. I'm going to run out of lead before I'm done with this. Minus 7. So I'm going to freehand this just because I'm not going to stop the video to go find a ruler. Okay. So here's a coordinate plane with my x-axis and my y-axis. And I need to figure out where this is at. This is, again, my vertex is at -1, -7, so I can just go -1, 1, 2, 3, 4, 5, 6, 7, -7. So there's my vertex down here. And then my a is 1/2. And remember our pattern, 1a, 3a, 5a, and so forth. If I multiply by 1/2 on each of these, I get 1/2, 3/2, 5/2. And we'll probably stop there. So anyways, from my vertex to graph this, I always want to go over by 1. It's always over by 1. It's that never changes. But up and down is this pattern. So I'm going to go over by 1 and up by just a half. And from there, I'm going to go over by 1, and I'm counting by halves here, right? Say I go up 3 halves. There's 1 half, 2 halves, 3 halves, puts me here. And from there, I'm going to go over by 1 and up by 1 halves, 2 halves, 3 halves, 4 halves, 5 halves to put me here. I'm going to do the same thing on the other side. So over by 1 and up by 1 half. Over by 1 and up by 1, 2, 3 halves. Over by 1, up by 1, 2, 3, 4, 5 halves. You didn't know you could count by halves, but you can. So we'll connect these dots, give us an idea of what that parabola looks like. Groovy, we graphed it. All right, that was 12. Somebody said 18 is a tricky one, huh? Let's see here. 18. I don't know what we're supposed to do. Down a little bit. There we go. What's the vertex form? Why yada. That's the same way as we just did on 15. I know. There's fractions involved. If there's fractions, it's a tough problem. Let's see. Could be a tough problem. Who knows? Oh, this is 18. 18. Y is equal to 2/3 x squared minus 8/3 x plus 5/3. Groovy. All right. Recall, we're trying to get y is equal to a times x minus h quantity squared plus k, trying to make it look like vertex form here. So we're going to go from here to here. And the way we do that is with a negative b over 2a, which in this case, our negative b would be a positive 8/3, because a negative 8/3 is a positive 8/3. 8/3 over 2 times a, which is 2/3, which would be 8/3 over 4/3. Now, remember when you were in elementary school and they taught you how to divide fractions, and the old-fashioned way was to say invert and multiply, but maybe later on they said keep it, change it, flip it, or something like that. But anyways, that's equal to 8/3, keep it, change it from division to multiplication. So we're going to be multiplying and flip it. That's that. So 8/3 times 3/4, and these 3's cancel, and you have 8/4, but 8 divided by 4 is 2. So that's our 2. That's our h. Okay, so we know h is 2. How do we find k? Well, for k, we go back and plug in h for our x's. So we're going to get 2/3 times 2 squared minus 8/3 times 2 plus 5/3. Okay, so we're just plugging in. Let's simplify. 2 squared is 4 times 2/3 is 8/3 minus 16/3 and plus 5/3. So 8 minus 16 is negative 8/3 plus 5/3 is negative 3/3, which we call a negative 1. Is that right? Oh, wait a second. Nay. 8 minus 16, yeah, is a negative 8 plus 5 is negative 3. Yeah, I could call it a negative 1. So we know what our h and our k are. And a, again, is just the same thing as what was here. That's a. So let's rewrite our equation in vertex form. This is y is equal to 2/3 x minus 2. That was our h squared minus 1. There's vertex form. Groovy. Groovy. And then there was one last one. 20. What does 20 say? Let's see. A gateway arch can be modeled with this function, y equals negative. It's not a very wide, it's a very narrow arch. 00635 squared plus 4x. In feet, how high above the ground is the tallest point? How high? And how far apart are the legs? All right, let's see if we can figure this out. Never seen the Gateway Arch, never been to St. Louis. Big stainless steel arch in the middle of town, I guess. How high is it? Well, we want to figure out what the vertex is then, right? If we want to know how high it is, we've got to figure out where the vertex is, because the negative in front of here means that this is an upside down parabola, right? So how do we find the vertex? Well, our magical negative b over 2a is going to tell us where help us find the vertex. So in this case, 4 is our b, and a strange number is our a. So that's going to be 4 over, let's not even show steps. Let's just plug it into a calculator, since we're going to be using that anyway. Hold on, I don't know if you can see that. Like, I can turn this on, but it's going to, maybe that'll help. I don't know. Be glary. So I'm going to do 4 divided by 2 times 0.00635. 314.96. Mr. Fokin, you didn't put negatives in. I know, but the top was negative and the bottom was negative. When you're taking a negative and divide it by a negative, you're going to get a positive. So turn that off so there's no glare. So 314.96, we're going to plug that in to find our K. 5 times 314.96 squared plus 4 times 314.96. Okay, just plugged in our H into the original, and again, I'm going to use my calculator to do this, because I'm not doing that in my head. No. 314.96 squared is that times 0.00635 is that plus 4 times 314.96. If I've plugged everything in correctly, I'm getting 1,889.8, let's say. All right. So how tall is how high is it? It's 1,889 feet, or approximately 1,890 feet. How how wide are the legs? Um, so let's think about this arch for a second. It goes up and maybe has a height of 1890 at the top, but at the ground, what's its height? If we were looking at this, the y values, right? The up and down y values are 1890 at the top. But what's the y value at the bottom where it's at ground level? 0, right? It's a 0. So what we're interested in doing then is taking this original expression and plugging in 0 for a y. Right? So all I did is replace there. Yep. Um, I can. Can I factor that? Is it factorable? Um, we can't. We can solve this, but we haven't talked about some of the tools we're going to learn in this chapter yet. So I think maybe maybe best to just say, let's use some technology. Let's plug this in. I've got negative 0, oops, negative 0.00635 x squared plus 4. It's not how to do the equals. All right, we're going to plug this in. Well, wait a tick. My math must have been off above because it says 1,000. You can get to 1,000. Well, anyways, let's look at this for a second. You see that there's a leg there. If this is our arch and the x-axis is our ground, we've got 2 points there. One of them is at 0, 0, so that's kind of nice. The other one is at 629.921. Well, that means that the distance from one leg to the other is got to be 629.9, or about 630 feet. So how wide are the legs? About 630 feet across. The one, like I must have plugged something in wrong on my previous one, because if we looked at just the top of the arch, it says it's 630 feet high as well. So I guess maybe the quickest way to do number 20 would be just to plot it on Desmos instead of trying to work with those funky numbers, and see where all these things are. But the top of the arch, by the equation, unless I've written that wrong, but I think it's okay, The top of the arch is at 630 feet, and then the legs across here are 630 feet across as well. That's kind of interesting. But anyways, that's how I would do number 20. Hopefully you guys are doing well. Good luck on everything else. Stay safe, and hopefully we'll talk to you soon. Bye-bye.